Hey everyone. So today we're going to be talking about time series and forecasting. So it should be a nice quick one today. So let's get into it. We're going to need a few new packages. So the first one we're going to need is called Fable. The second one, tsibble. And then the third one is going to be tsibble data. And then of course we're going to need tidyverse like we have since the beginning. This one, tsibble data, we only need for this demo. So when you guys are writing your homework assignments, you're not going to need this one, okay? That we just need it because the data that we're going to be using in this demo is going to be kind of loaded into this package, okay? Let's load these up and take a look. Oh, and let's get rid of this thing, put it somewhere else. Okay, awesome. All right, so the data that we're going to be using is called OS retail. So if we look at this, it says 64,532 rows by 5 columns. It's a panel data set. So we have in each state in Australia, for each type of industry, in each month, we're going to observe this thing turnover, which is like a measure of sales. Okay. So OS retail is already this thing called a T-Sybil. What's a T-Sybil? It is a data table that's like time series TS formatted, which means it has an index, like a time index that R can kind of recognize. So this data is already a T-Sybil. When you guys load up your data, you're going to need to convert it to a T-Sybil. So after you load in your data, let's say the data is called my data, you're going to need to convert it using the command as tsibble. Okay, that should be right. As, yes, as tsibble. So you're going to take your data set that you loaded, and then you're going to need to provide index, which is which of the columns has the information about the time period. And the data you're going to be using, that index or that column is going to be date. Okay, so that's something you're going to need to do. But we don't need to do it here because it's already this T-Sybil. So you can see OS retail is a panel. So for us, we're just going to take a small subset of this panel. So we're going to filter our data, only looking at the state of Victoria and only looking at, I think the industry that we can do is department stores. Let's take a look at that. Department stores. Awesome. So we'll run that. So we have our DAT. It's 441 observations with 5 variables. So the first thing that we can do, and a really nifty part of this package, is this command called autoplot. Autoplot just takes as its input the data set, and it's going to create a nicely formatted plot of the time series that we can look at and learn a little bit. So here it is. We can see on the x-axis is the month, on the y-axis is turnover. And we can see that there's like a few things. One, the data is trending upwards over time. Two, there's like this very strong seasonality, right? Every year, it looks like there's a big spike in sales, which probably corresponds to holiday time. Okay. So we can already kind of see like, yeah, we're going to need a model that allows for a trend and that allows for seasonality. The good news is that this package Fable, which is what fits the time series plots, is extremely user-friendly. How user-friendly is it? So all we need to do is specify the class of model that we want. In this case, let's start with an autoregressive model because that's the first one we learned about in class. And then all we need to do is specify what is our Y variable. That's it. We do that, and then we run it. And what we get is this like fitted object, which is basically this package's best AR model. When I say best AR model, it considers AR models that have seasonality, that have different levels of lags, and that also have potentially trends or drift. And it chooses the best one based on which of the AR models minimizes the root mean squared forecast error. Okay. So it's already kind of done all this work for us in the background. So it's created a fitted model. This is like the output of LM, but we haven't had to specify anything really. It's sort of done the work for us. Okay. So now let's take our model and let's see what kind of forecasts, how well does it perform? So we can use this command forecast. Let's forecast for 24 periods. Because our data is monthly, that means we're going to be forecasting for 2 years into the future. We run that. And then we can use autoplot and plot the data alongside the forecasts. Okay, so it looks like forecasts come first and then your data set. So what we can see here is we have our data like before, and then on the end of it, we have 2 additional years of data. We have kind of a central line where that's our kind of prediction, our y hats. And then we have these confidence bars around it at the 80% level and then at the 95% level. Okay. The last thing that we can do is we can assess the fit of our model using this accuracy command. So accuracy, basically there's a lot of different accuracy measures. The one that we learned about in class and focus on is this one root mean squared error. So this is the performance of the model in terms of kind of the sum of squared residuals between like the forecast and the prediction, or between the forecast and between the actual data. So that's it. Your task this week with the homework is going to be to get the model that is going to forecast the best. Now, there's a lot of different models you can pick from. So we talked about AR in class. We also talked about the ARIMA model. For this Fable package, you can go to this link and you can see all the different things that instead of AR, you can put in here. So you can put in ARIMA, you can put in stuff that we didn't learn, like neural networks. So you can try out different things. Now, in class, I mentioned kind of like there's this bonus for whoever has the best predicting model. What I want to be clear about is that it's not going to be who has the lowest root mean square error on their model. It's going to be for the data that you haven't seen yet, which is going to be kind of the next week after the end of the data set that you have. So once that week of data comes in, how well do your model's forecasts line up with that data in terms of minimizing the root mean squared error, forecast error of that unseen data? Okay. So we don't know what that's going to be yet, but whoever's model has the lowest root mean squared forecast error on that unseen data is going to be the winner. Okay. So that's it for this week, actually. So it's very, very straightforward. You're estimating these time series models, you're getting the forecasts, you're evaluating the performance. So yeah, good luck with your homework, and I will see you guys in class.